No matter how well they are maintained, rolling contact bearings, like all other bearings, eventually wear out and are subject to failure. Regardless of the type of bearing or the conditions under which it operates, all bearings eventually wear out and have to be replaced. In this part, we'll watch a procedure for removing a ball bearing, and we'll see a procedure for cleaning and inspecting a bearing to determine what caused it to fail. Before starting the procedure, the mechanic checks the equipment manufacturer's manual for proper instructions. He will also check his company's procedures for bearing removal. This shaft was removed from a piece of equipment that has been tagged and locked out for maintenance. To remove the bearing, the mechanic must first remove the locking nut that secures the bearing to the shaft. The locking nut is threaded onto the shaft and secured with a locking washer. To remove the nut, the mechanic bends the tab on the locking washer out of the way. The mechanic uses a special tool to loosen the nut called a spanner wrench. The spanner wrench fits the span between the notches on the nut, allowing firm pressure to be applied to loosen it. Once it is loose, the nut is backed off the shaft by hand and the washer is also removed. Now the mechanic can remove the bearing. To make it easier to remove the bearing, the mechanic uses penetrating oil to lubricate the bearing's inner ring where it contacts the shaft. Then the mechanic places the puller jaws behind the bearing and adjusts them so that they rest loosely on the shaft. He connects the rest of the puller to the puller jaws by hooking the curved ends of the side rods to the outside edges of the jaws. He turns the lead screw by hand to take up the slack between the strong back and the puller jaws. As he does this, to ensure that the bearing puller will be properly aligned, he adjusts the side rods so that they are parallel to the shaft. To make sure that pressure is applied only to the inner ring of the bearing, the mechanic checks to see that the bearing still turns freely. Applying pressure to the outer ring or rolling elements should be avoided, otherwise the bearing could be ruined. Using a wrench that fits the end of the lead screw, the mechanic now tightens the bearing puller to apply force on the bearing. As the force is increased, the bearing slowly slides along the shaft until it can be removed by hand. After the bearing has been removed, the mechanic cleans it thoroughly in a solvent bath. Once the bearing has been cleaned and dried, the mechanic inspects the bearing for signs of wear, spalling, and discoloration. He rotates the bearing rings slowly to make sure that they are able to turn freely. If the rings turn hard, bind, or drag at any point, the bearing should be inspected further for dirt or other obstructions. This bearing shows no signs of unusual damage and has simply worn out from normal use. To prevent this bearing from being mistaken for a new bearing, the mechanic disposes of the bearing according to company procedures. In this part, we'll view a procedure for installing a new ball bearing on a shaft. This shaft was removed from a piece of equipment that has been tagged and locked out according to company maintenance procedures. Before installing a new bearing, the mechanic cleans and inspects the shaft for signs of damage. Any small imperfections on the surface of the shaft, such as burrs or scratches, can be removed by carefully polishing the shaft with a fine emery cloth. When imperfections are removed from the shaft, care should be taken to avoid removing too much metal from the shaft surface. If the shaft is polished excessively and too much metal is removed, the shaft may become too thin to fit the bearing. The next step is to prepare the shaft by applying a light coating of lubricant. Once the shaft is prepared, the mechanic unwraps the new bearing. To avoid getting them dirty, new bearings should be left in their protective packaging until they're ready to be used. Since this is not a sealed bearing, the mechanic must pack the bearing with grease by hand before it is installed. The mechanic uses a grease that is recommended by the equipment manufacturer. Generally, when a bearing is packed by hand, to avoid filling the bearing with too much grease, it should be packed 1/3 to 1/2 full. Once the bearing is properly packed with grease, The mechanic slips the bearing onto the shaft. As he does this, he is careful not to catch any metal or dirt particles between the bearing and the shaft. To obtain a secure fit, the mechanic will tap the bearing into place. To prevent damage to the bearing, the mechanic will use a metal sleeve known as a tubular drift. The tubular drift is designed to slide easily over the shaft. The mechanic places the drift over the shaft and makes sure that it contacts only the bearing's inner ring. Pressure should never be applied to the outer ring or rolling elements. The mechanic then taps the drift with a mallet to seat the bearing in place. Once the bearing is in place, the mechanic replaces the locking nut and washer. The tab on the lock washer is also pressed back into place.